Have you ever tried to get your head around all of science at once? To actually see how everything, from pure math all the way to artificial intelligence, really connects? Well, one person, Guy Lakeman, actually tried to do just that on a single, massive chart. So today, let's dive into this wild attempt to map out the entire universe of scientific knowledge.
I mean, talk about setting the stage. He kicks things off with this incredibly bold statement. It's not just a collection of facts we're looking at, it's a challenge to see the whole entire picture. And as he puts it, to do that, you're going to need a brain the size of a planet. So, the guy who made this chart, he doesn't think of science as just another school subject. No, he frames it as a giant interconnected puzzle. He calls it a Pandora's box. Once you crack it open, there is no closing it again. And here it is, the chart itself. It is sprawling, it's dense, and everything seems connected to everything else. But what's so fascinating is where it came from. This wasn't supposed to be some finished final document. It was literally designed as an interactive wall chart for students to just scribble on and draw their own connections as they learned. And this really gets to the heart of the whole thing. The philosophy here is that scientific knowledge isn't some fixed set of rules. It's a constantly expanding universe of ideas. Just like that Pandora's box, once you open it, it just keeps going. You can always add new stuff, new discoveries, but you never ever take away what's already been learned. Okay, so where in the world do you even begin with a map this huge? Well, according to this chart, it all starts with the one foundational language of the entire universe, mathematics. On this chart, math is defined as the very language that science speaks. It's not just about numbers and equations. It's the fundamental tool we use to describe literally everything, from the orbit of a planet to how a chemical reaction unfolds. It's the absolute bedrock. And would you believe, this language has been in development for thousands of years. I mean, from Pythagoras declaring that all is number over 2,500 years ago, through Euclid's geometry, all the way to Newton inventing calculus. Every single step just built methodically, logically on the one before it. Until this happened. Right around the turn of the 20th century, thinkers like George Cantor came along with these mind-bending concepts like multiple infinities and chaos theory, and it just blew thousands of years of mathematical tradition completely apart. It's such a powerful reminder that science doesn't always move in a straight line. Sometimes it just leaps forward with these incredible, disruptive ideas. Okay, so we've got the language of math all set up. The chart then moves to the next layer up, the discipline that uses that language to describe the very fabric of reality itself, and that, of course, is physics. At its core, the goal of physics is to answer maybe the biggest question there is. How does the universe actually work? It takes all those abstract rules from math and applies them to the real world, to matter, to energy, to space and time. And the scope is just huge. I mean, look at this. Every single branch you see here is basically using math to try and carve out and explain its own little piece of the universe. All right, so we have the language, which is math, and we have the fundamental rules of the universe, which is physics. Now, the chart shows us how those things combine to create the building blocks of matter and, eventually life itself. This slide just lays it out so perfectly. You can really see the hierarchy, this kind of cascade of science. Math gives us the language, so physics can describe the structures. And physics lays out the rules for chemistry's atoms, and then chemistry provides the foundation for biology's organisms. It's like a stack of building blocks. Chemistry is the great connector here. It's the science of how all those fundamental particles that physics talks about come together to form everything we can actually see and touch. From a rock to a glass of water to the very molecules that make you, you. And right at the top of this particular cascade, you get biology. It's the study of life in all of its insane complexity, and it's built directly on top of the chemical reactions and physical laws that came right before it. It's basically the point where the whole system starts to become self-aware. And just look at the unbelievable diversity that pops out from these simple foundational rules. I mean, from a single-celled organism all the way up to plants and animals, biology just takes the basic code of chemistry and physics and spins it into this incredible spectrum of life. But the chart doesn't stop there. It doesn't even stop with us humans. It extends into what might be the newest and maybe the most transformative field of them all, artificial intelligence. Hey, remember that brain the size of a planet from the very beginning? Well, this is where it all comes full circle. The author sees the human brain as amazing, but limited. In contrast, he suggests that machine learning and AGI systems can do the one thing we can't: connect to this entire web of knowledge all at the same time. And according to the chart's creator, this is not science fiction. It is happening right now. He really argues that AI is the fulfillment of that initial challenge. It's the creation of an intelligence that's finally vast enough to actually understand the whole system.
And he makes sure to credit the modern pioneers who are pushing us into this new age, people like Geoffrey Hinton and Demis Hassabis. In his view, these are the Newtons and the Euclids of our generation. So let's just pull back for a second and look at the big picture one last time. What is this chart really all about? Because it's way more than just a list of names and dates. It's a whole philosophy. And it all comes right back to this. This chart is meant to be argued with, scribbled on, and added to. It really drives home the idea that the map of science is never, ever finished. It is a work in progress, just like science itself.
The creator leaves us with this really powerful and, a definitely provocative final thought. Considering the immense complexity we've just seen, he argues that telling someone to follow the science without helping them understand it is, and these are his words, cruel. That's a pretty profound statement about the responsibility that comes with having all this knowledge.
Which really just brings us to the final question for you. The author wanted this chart to be drawn on, to be expanded. So if you were standing in front of it right now with a marker in your hand, what new connection between all these vast fields of knowledge would you be the first one to draw?